In this video, we're going to talk about systems of equations, and a system of equations is when we have two or more equations with two or more variables. So for Algebra 1, we will only be looking at two equations with two variables. Later on in math, you may encounter a system of equations that has three equations, and you have to solve for x, y, and z. So we're keeping it to two for this year, but do know that it could expand and get larger in the future. And when we are solving a system of equations, the solution is the set of values that makes both equations true at the same time. So when we are solving a single equation, we are finding the one value that you could plug in for x or whatever your variable was that made that equation true. In this case, we have to figure out what does x have to be, and at the same time, what does y have to be so that both of the equations stay balanced or true. We are going to be focused on systems of equations with two equations and two variables, as I said earlier. And our solutions will be written as an ordered pair. And when we get to the third video, this will make a little bit more sense why we're writing our answers as ordered pairs. But just know that is the notation. Oh, I guess we don't need the S on there. So we're going to look at three different methods for solving systems of equations. Each method is going to be its own video, its own lesson. So the first one is going to be substitution, and that's what this video is going to be focused on, other than this overview here. The second video, or video B, is going to be on solving using the elimination method. Those two are going to be the harder ones. I always save graphing for last so that last lesson isn't quite as heavy. So the final one is graphing. You do need to make sure you understand substitution and can do that successfully before you move on to elimination. Elimination does use some parts of substitution in it, so these things do build. All right, so let's go ahead and get started with this first method, solving with substitution. So each method kind of has an ideal situation as to when you would want to use that versus some of the other methods. So substitution is going to be your best method when one variable is already isolated. Let's fill in this in. So substitution is the best method for solving a system of equations when one variable is already isolated. In other words, one of those equations is already solved for x or already solved for y. You can certainly use it in other situations. It may just be more complicated, might be longer, might just make a much messier problem to solve. So we have four examples here. In this first example, I actually have both. Well, so I guess I should back up. This is what a system of equations looks like. You have this curly bracket, and you have two equations. Each equation has two variables. And so when I'm looking at this one, I know that substitution is going to be my best method because I have not just one, but both equations solved for x. And so what this means is x is the same thing as 3y minus 4. And so if they're the same, if they're equal, I can replace this x in the other equation with the 3y minus 4. So I'm going to rewrite, instead of putting x, going to the other equation, writing 3y minus 4 equals, so that all went in for the x here. And so this y minus 2 is still going to be there. And the reason why I want to do that is because I can't solve an equation that has two unknown things in it. So I need to find ways to rewrite my equation so that there's only one variable. So I made this substitution. I replaced the variable x with something that it's equivalent to that has y. So now this equation only has y's, and that's something I can solve. I can figure out what y is equal to. So I have variables on both sides. We're going to subtract y. These are going to cancel out. 3y minus y is 2y minus 4 equals negative 2. Add 4 to both sides. So 2y is equal to 2. I'm running out of space here, but divide by 2. And so now we see that y is equal to 1. So we're not done. We're halfway there. We now know what y is equal to. And so now we have to take this value that we know and plug it back into either of these equations. It doesn't matter. You get to pick here. So you get to pick which one you think is easier. I'm going to go with the bottom one. So x is equal to 1 minus 2. And 1 minus 2 is negative 1. So now I know what x is. So my final answer is negative 1, 1. And if you look at the notes key that's posted in Google Classroom, you'll see that for this second part, I actually plugged into the other equation. That's the kind of nice thing about this. It doesn't matter. Once you've found that first variable, it doesn't matter which equation you plug into the second time. You just plug into whichever one you think is a little bit easier. All right, here's our second equation, or second systems of equations, and I see that this first equation is solved for y, so that's nice. But when I look closer, I notice that this second equation actually only has y. So while this is a system of equations, sometimes one of the equations is so simple that I don't even have to start out with a substitution. This right here is an equation with one variable that I can solve. So I'm going to solve 7 equals 2 minus y for y. Then I'll know y and I can go find x. So number 2 is actually a little bit easier than number 1. So I'm going to subtract 2 from both sides. 7 minus 2 is 5, but that's equal to negative y. Remember, that is attached to the y. So I'm not quite done. I need to get rid of that negative. So now I know y is equal to negative 5. So now that I know y, in this case, plugging into the second equation doesn't help me. So I'm going to have to go to the first one because that's the only one that also has x. But I know that y is equal to negative 5, so I'm going to replace the y with negative 5. And now I can solve for x. So minus 8, those cancel out. Negative 5 minus 8 is negative 13. But this is still a negative x, so I need to get rid of the negative. So x is equal to positive 13. So when I go to write my solution set, I have to make sure I put the x value first, so 13, and then the y value, which is negative 5. All right, 2 more examples. In this this should be a 3. Sorry about that. In this third example, when I look at the two equations, both equations have x and y, but the first equation is already solved for x. So that's going to be my easiest way to proceed with my substitution. So I'm going to be replacing this x with negative 2y plus 4. So all the other parts of the equation stay there. I just replace the x with this thing that it's equivalent to. So 3.5 times negative 2y plus 4 plus 7y equals 14. All right, and now I'm going to solve this for y. First things first, we're going to distribute. 3.5 times negative 2 is negative 7y. 3.5 times 4 is going to be positive 14 plus 7y equals 14. I still have two variable terms, and when I combine them, because they're on the same side of the equation, no inverse operations, when I combine them, negative 7y plus 7y, well, those two cancel each other out. And all I'm left with is 14 equals 14. And that is a true statement. So just like with equations, when you're left with a true statement, that means your answer is infinitely many solutions. In this case, we don't want to say all real numbers. We do want to say infinitely many solutions. If your variables were to have canceled out and you were left with an untrue statement, it would be no solution. So similar to just solving a single system of equations. But we don't have to do any sort of substitution. We don't have to go back and solve for anything else. Once those variable terms have canceled out, we can see that this is our answer. Our last example, both equations have both x and y, and neither equation is solved for one variable. But when I look at the first equation, I see that I could solve it for x fairly easily just by moving this 3y over to the other side. It's actually going to simplify nicely because I have a y here and a y there. So when I subtract 3y from both sides, I don't know why this is up here. There we go. 4y, oh, goodness, minus 3y is going to become y plus 3 equals x. So when I moved this to the other side, this is the equation that I got as a result. And so this is solved for x. That means in this other equation, everywhere I see an x, I can replace it with a y minus 3. So down here, we're going to have 2 times y, I think I said minus 3, y plus 3. Y plus 3 plus 4y equals 18. So I have one equation with one variable, and I'm going to solve for y. So we're going to distribute. We get 2y plus 6 plus 4y equals 18. Combine my like terms to get 6y plus 6 equals 18. Subtract 6 on both sides. We have 6y equals 12. Divide by 6. This is just solving a single variable equation. So we get y is equal to 2. And again, I'm kind of running out of space here. I'll write it over here. Y equals 2. I'm not very good at keeping it super neat on the screen. Sorry about that. So now that we know what y is equal to, we can plug into either equation and solve for x. I'm going to pick the second equation so that I don't have to plug in a 2 in two separate places. So I'm going to do 2x plus 4 times y, but now I know y is 2, equals 18. So this is going to be 2x plus 8 equals 18. Minus 8 on both sides. We have 2x equals 10. Divide both sides by 2. And my final answer here is that x is equal to 5. Or so, not my final answer, but my x value. So my final answer is 5, x value first, 2. And normally I don't like to put my answer in the middle of everything, but like I said, I'm having a hard time writing very neatly on the screen today. So, a couple things to note. It looks like on all of these, we were able to get x all by itself and then make a substitution in, and we solved them all for y first. That's not always going to be the case. It's just that these particular problems that I chose were that way. Sometimes it might be easier to find that y is equal to something and make a substitution for y and solve for x first. Doesn't matter which variable you solve for. It's really going to depend on what the problems look like and kind of, which variable is easier to get alone. So don't feel like when you're solving your homework problems that you have to solve for y first. It's just kind of a coincidence of the problems that are here on this page. So this is the end of the A notes. You are now able to choose either the mild or the medium assignment from the top row of the choice board to practice this. None of the spicy assignments would be a good place to start because you need to know all of the methods before you can do those. So I would pick either the mild or the medium for substitution, get a little bit of practice with that, and then once you feel like you've mastered it, come see me to take your mastery check.